We're nearing the end of the series of lectures, and the last thing we're going to talk about in this section and the next is going to be the logarithm. So let's consider this exponential function, 10 to the power of x equals y. So this function, if we think of this as f of x equals 10 to the x, we can get rid of that y just for all intents and purposes. It turns out this is a one-to-one function, so we can find an inverse that goes in the opposite direction, and we call this inverse the logarithm. So we call the inverse of this function the logarithm. And we write it this way. So, oops, I forgot to write something. I don't want to make that italics. Okay, so this is the logarithm. So let me give a sort of formal definition of a logarithm. So log base a of b, that's what we call it, log base a of b, is the solution to a to the power of x equals b. And in this case, a is the base. So notice something, oh, new line. So notice something pretty important. A is the base in the logarithm. A is the base here. So if you express something as a logarithm, or if you express something as an exponential function, it remains the same. The base will be the same in both the logarithm and the exponential function. That's kind of important to remember, because that's how we can remember how to deal with how to switch from one to the other. So whenever we have an exponential equation, I'm talking a full equation that actually has an equal sign, we can rearrange it in logarithm form. So let me go ahead and write that down. Whenever we have an exponential equation, we can rearrange it in logarithm form. Okay, just a second. Okay, let me move a little bit this way. So, for example, we have 5 squared equals 25. Okay, well we know that 5 squared is equal to 25. So we can write it as log base 5 of 25 equals 2. All I did was I'm rearranging this function in logarithm form. So let me go back again to explain exactly what it is that we're doing. We're coming up with a new function. Okay, this is how we go from f of x equals 10 to the x. This is how we invert that function. So 5 squared equals 25. We can rewrite that in logarithm form as log base 5 of 25 equals 2. So think of it this way. Let's say we don't know what 2 is. I'm sorry. Let's say we don't know what the right side is. Okay, so we're looking for a solution to 5 to the power of x equals 25. Well, we know there can only be one number where that works, and that's going to be 2. So x equals 2. And that's the definition of logarithm. The logarithm is the solution to this equation. Okay, so let me clear that off. Now, let me explain exactly how I can quickly and easily go from this to this. So I'm going to write this out again, but I'm going to do it with a little bit more space. So 5 squared equals, a little more to the right, 25. So the base, remember, will stay the same. I mean, you'll have, here the base is subscript and here it's not, but even so, it's still the base. The base is still going to be the same. So we start with the base, go over 25, and then over to the equals, then over to the square. So we're going counterclockwise. So you start with 5, go over to 25, then to the equals, then to the 2. Start 5, go over to 25, then equals, then 2. So let me do a couple more examples just to nail it down. So for the next example, oops, I put it in the wrong place. Okay, so for example, let's say that 3 to the 4 equals 81. Okay, that's something that we know. We can all agree that 3 times 3 is 9, so square 9 and you'll get 81. So let's write this in logarithm form. So I'm going to go ahead and write this with a little bit more room. 3 to the power 4 equals 81. So I start out with log, because I want to put this in logarithm form, and the base is going to be the same. It's going to be 3. So then we want to go to the next part. We go counterclockwise, so we go over to 81. So log base 3 of 81, and then keep going counterclockwise, equals, and you could skip the equals, really, because it's kind of obvious, equals 4. So log base 3 of 81 equals 4. Let's go ahead and write that. So log base 3 of 81 equals 4. And the reason why is because this is going to be the solution to the exponent. So if we had 3x equals 81, then, well, we can write this as a logarithm, where log base 3 of 81 equals x, because by definition that's what the logarithm is. The logarithm is the solution. It's the exponent. And then we know that 3 to the power of 4 will equal 81, so x will equal 4. But the point that I'm trying to get at here is that this logarithm is going to be the solution to this equation. So let's go ahead and go on to one more example. And this is one that we've pretty much already seen, but it doesn't hurt to do it again. Well, not really do it again, but do it with a new perspective, I guess you might say. And that's 10 to the power of x equals y. That's pretty much what we talked about right here. So 10, okay, let's scroll down a little bit. 10 to the power of x equals y. So I want to go, I have log base 10. So start with a base, go over to counterclockwise of y. So log base 10 of y equals x. And you can kind of see that I skipped the equals this time, just because it's pretty understood. I already know what it is. So log base 10 of y equals x. So let's build a little bit on this and see exactly how this is the inverse of f of x. So let's say that, oh, first of all, let's go ahead and write that down again just so we can see it more easily. So log base 10 of y equals x. oops, sorry, had a code mistake. So log base 10 of y equals x. So let's write it this way. So we write it as f of x equals 10 to the power of x. And so that means that the inverse of that function is going to be f inverse of x is equal to log of x. Oh, sorry, new line. So this is the original function. This is the inverse of that function. So let's go ahead and plug different things into it and see what happens. So let's say f of x equals 10 to the x. So let's find f of 2. F of 2 is going to equal 10 squared, which is equal to 100. So f of 2 equals 100. Now let's do f inverse of 100. So that's going to be log, oops, I forgot to put the base here. Sorry about that. Log base, oh, I did the same mistake there that I did before. Log base 10 of x, so is going to equal log base 10 of 100. So this log base 10 of 100 is going to be the solution to the problem 10 to the power of x equals 100. That's by definition what the log is going to be. It's going to be the solution to this problem. So what is x going to be? Well, x is going to be 2. So f inverse of 100 is 2, and so we can see that it's the inverse of the function. Whereas f of 2 mapped to 100, f inverse of 100 mapped to 2. So we can kind of see how it's the inverse of the other. Now, we can also go the other way around. We can go, I mean, from these examples, we went from exponents to logs, so log base 3 of 81 equals 4. Now we can go the other way around as well. We can start with a logarithmic function and go to an exponential function. So example for going the other way. So let's say we have log base 2 of 8 equals 3. Okay, well, it's actually the exact same type of thing. We also go clockwise. We still go from, so let me write this out with a little bit more room. So log base 2 of 8 equals 3. Okay, well, we have 2. 2 is the base stays the same, to the power of 3 equals 8. So now I've gone from one direction to the other. And I think we can agree that 2 cubed equals 8. So that means, let me go ahead and so log base 2 of 8 equals 3 implies that 2 cubed equals 8. I've just gone from the logarithm form to the exponential form. So one more time, I started out with the same base, went over to 3 for the exponent, and then over to 8 for the final part. Okay, so let's clear that off and do one more example like that. So we have log base 3 of 9 equals 2. So, like before, I'll go ahead and write it out with a little more room. Should be G. Log base 3 of 9 equals 2. So start with the same base, 3, go over to the 2, 3 to the power of 2 equals 9. Whoa, that's a long 9. So 3 to the power of 2 equals 9. I just changed it from the logarithm form to the exponential form. Let's go ahead and write that. So we have 3 squared equals 9. Okay, so that means here's a summary of the basic logarithm function, the super important logarithm function. So if you have this exponent function, if you have this equation, then this is a rearrangement of the same equation. It's kind of like going, okay, so if x plus a equals b equals y, let's say it's y, then we could subtract a from both sides and we'll get x is equal to y minus a. We can say that they are both true. It's the same thing over here. If this is true, then this is also true. So we can rearrange the equation to solve if we need to, and we will. Well, we won't be going into too much detail on that, but this is the basic idea. You will in the next class, though, go into a lot of detail on how to use these logarithms. So, just like you can go from this equation to this equation, you can also go from this equation to this one. So let's erase that because we don't really need that anymore. So if a to the b equals x, then log base a of x equals b. And if you wanted to, in fact, I'm gonna no. Okay, I was going to say I'll rewrite that switching the x and the b, but it doesn't really matter. The point being that the base stays the same, and these two parts, in a manner of speaking, you could say that these two parts switch, and of course you add the log to the a, to in front of the a, I mean. So this is something that you really need to remember. It's very, very important. You're going to see this a lot in the next algebra class as well. And there's two specific types of logs that you'll see a lot too. Let's go ahead and I wrote them down before, I'll go ahead and copy them. So there's two logs that you'll see a lot. The first one is called a common log, and it's base 10. And usually if you see log and there's nothing attached to it, there's no base written, that means base 10. That's called common log. You're going to see that probably on your scientific calculator. And the next one you'll see is natural log. You will actually see natural log probably a lot more than common log. The base is the magic number e, and it's written as ln. It stands for natural log. I assume it's probably Latin, which is why it's in the opposite order. It's ln instead of nl. So natural log of x, base is e. Remember that e is approximately, wow, that's bad approximately, isn't it? 2.71828. So remember that's the and there's ... because it's an irrational number. It can't be written as a ratio of two whole numbers. So the common log will have base 10, and if you see log with nothing attached to it, no base on it, then that means base 10. And if you see ln, that means natural log. So I'll go ahead and write that out as natural log equals log base e of x. Okay, so I didn't mean to scroll down. I didn't scroll up. So natural log of x means log base e of x, but you're almost never going to see this. I think there are actually a few examples in the homework that are like this, but overall, this is the way you'll see it, and there's probably something in your calculator that says this. Once in a while, when you get into some later math classes, much later, but the reason why I say this is because you might see this elsewhere. Like if you go to a math message board or something, you might see this, like for helping your homework, and they start using log. When they say this, what they really mean is this. Sometimes some older math textbooks, some computer programs, and some higher level math textbooks will say log of x, and what they really mean is natural log of x. Okay, well, I've rambled for enough time here. I will see you in 12.4. We are skipping 12.3 and going straight to 12.4. See you then.